Okay, I'm just going to do a couple of examples. Hopefully that will help some of these questions. Which diagram shows the most useful positioning and accurate labeling of a kite in the coordinate plane? Well, let's think about that. So this one, it doesn't complete the kite, so I don't think that's the most useful. Remember, most useful positioning, what we're trying to figure out. So I can rule that one out. I can rule this one out. So now let's look at A and B and think about what they're showing us. Well, this one shows coordinates 0C. This shows 0C. This shows negative A0, negative A0. This one shows B and 0, B and 0. And this one shows 0, negative C. Well, look at this. This shows 0, negative D, which I'm not sure that's going to be accurate labeling for this kite, since we know that this distance here, this C on the y-axis, has to be the same down here. So we know this is cutting right through the x-axis. So we know that this is going to have to be congruent here with this here, and this one is. So this would be our most accurate labeling, would be this D for this one. I'm using real examples because I think you might see these on the test. Just saying. Okay, let's look at this one. Which diagram shows the most useful positioning, again, of a square in the first quadrant? Well, what I like to do is rule some out. And this one is not on the x and y axis. So we're talking about useful positioning. This one's on the x-axis but not on the y-axis. I'm gonna rule those out right away. This one is on the x-axis and the y-axis, and it is obviously the easiest to work with. The midpoints, everything are the easiest to find. This one is turned. We've turned that square, so it's not nearly as easy to work with as this one. So the most useful positioning of the square is C. Okay, this is one, oops, and that. Slide that back up. All right, this is one that kind of models one of your questions. So this says, for the parallelogram, find the coordinates for P without using any new variables. So we've got variables of A, B, P, 0, C, but we're trying to find out what this point here is. Okay, and we know it's a parallelogram, so we know that this is the same distance as this. So what's that tell us? Well, that tells us that our x-coordinate A plus our x-coordinate here of C. So to get from this point, change colors. To get from this point to this point, we're going to have A plus C. That'll be our x-coordinate. Well, our y-coordinate's really simple because it's right here. So it's B. So my coordinates of P are A plus C for x and B for y. Hope that makes sense. Okay, in this one it says triangle TVS. Is triangle TVS scalene, isosceles, or equilateral? So it gives us these vertices, 1, 1, 4, 0, and 3, 5. So I'm just going to draw this triangle and see what it looks like. So I've got the point 1, 1. Oops, got to put some color on here. Got the point 1, 1, And I've got the point 40, 1, 2, 3, 4, 0. And I've got the point 35. 3, 1, 2, 3, 1, 2, 3, 4, 5. Right? So, if I simply draw this nice and straight-ish, well, that's not too bad. Could be worse. Well, we should be able to look at this and realize that it's clearly not equilateral. It clearly can be determined. It's not isosceles. Remember, the isosceles triangle would look, something like this. Oops, gotta undo that. Oh, thing jumped off the screen on me. Right, where these would be congruent. And it's clearly not that. We can see our points here. So this is a scalene. This is scalene. So let me look at your questions again. There they are. On the new corner place. Okay, so hopefully now you know how to find the midpoints. That was in your formula thing. Okay, and these examples I showed you, you will see again. So I think that'll probably help. So great, it wasn't recording. Oh yeah, it was recording. Okay, so I think we're done.